So, hello everyone, this is DEEPAK Joshi, and today we are going to solve a very interesting problem statement from LeetCode, that is same tree. In this given particular problem statement, we have given the roots of two binary trees, that is P and Q, and we need to identify whether the given binary trees are identical or same or not. Uh, so what are same binary trees? Let's go through the definition. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. So in that regard, like 1, 2, and 3, this sort of tree is identical as well as same with the other one. Like let's go through this with very interesting examples. Here, we have given 1 and then 2 and then 3, and then in another uh, binary tree like this. So these two are identical because the left node of this particular root, I'll call it root 1, and the right node of this, I'll call it root 2, the left node of this one as well. Both are same, and similarly for the right node of R1 root and R2 root. That's so interesting. But if we'll go through the another example that is given to us, that is this one, 1 with the left node as 2. So this is our R1, the L1, the left node for this is 2. But the other node that we have given is R2. The first node is pretty similar and same with the same value, but it has no left node. The right node to this is 2. This is R1, or I would say R2. So look here, these may be identical, but they are not same because the values are not same. These are not even identical, I would say, because the left child in this one is available, but the left child here is null and the right child is available. Let's take an example of an identical tree. The identical tree can be 1 and 2, and let's say this is 3, and then here it can be 3, 2, and 1. So here R1 and R2 have left and right child, but they are not the same. These are identical, sort of structurally, but not same. Let us take another example that is given to us. Like we have already covered, uh, we can easily cover this one. We have given 1, 2. I think I'm cropping myself now, like cropping diagram now. Yeah, 1, 2, and we have given 1. And then we have given another one, that is 1 and 2. So here the values are pretty same, 1, 1, 2 in both the cases, but the output that they are not same actually, because the left of first root, that is R1, is 2, but the left of this is not 2, it is 1, and the right node is also pretty different. Like in that regard, we cannot say these are not same. Okay, that makes our thinking pretty clear. How will we approach this sort of particular problem statement? We need to think. What we need to check is first whether roots are equal. If somehow we will be able to check if the roots are equal, then we need to identify whether, like I'll just, yeah, whether the uh, left and right child are equal, right child are same. If we were somehow able to figure out these two things, then what we need to do is we need to do it recursively for everything. What do I mean by that? Let's try to apply this with the standard example that we had. We had this example, that is 1, 2, and 3, along with 1, 2, and 3. Makes sense. Now, what we'll do, we'll compare the roots. 1 and 1 are equal, tick. Let's compare, this is the roots. Then let's compare the left. How we'll get the left? We'll call it recursively and we'll get left. We'll see left is 2 for the left one, and then 2. So this is for R1 and this is for R2. It is tick. And then we'll check the right. in that regard, 3 is equals to 3. But right, let's take a complex example. I will take a 1, 2, 3, 4, and 5. Here 1, 2, 3, 4, and 5. Okay, this is not the most complex example present in the market, but it's more like we can understand a lot of things from it. So how we'll approach this particular thing? We'll compare the root. I'll call it R1, I'll call it R2. So R1 and R2 are equal because 1 is equals to 1. And then we'll check the left node of R1, that is, I'll call it L1, and then we'll check whether L1 is equals to L2. We'll see 2 is equals to 2. Let's make it interesting. Let's make it 6. Yeah, that's nice. Now in we'll check the right of the R1, that is R1. We'll compare it with R2 and we'll see 5 is equal to 6. No, all these were the cases. So in that case, these are not same and I will return false. And let's say somehow it was 5 and we were able to do that. Then we'll do a recursive call for these three things for this two. And in that, I think I need to, yeah, for this two, we'll recursively check for 3 and then for 4. And similarly, for this 3 will do and for 4 will do. I think I was able to make myself clear. I think I was able to explain what I'm thinking and how we would like to approach this particular problem statement. Now, there's a very small thing remaining, that is coding. Like, I think programming nowadays is pretty easy. You just need to identify how we'll approach the problem statements and then we'll be able to code it easily. So now let's try to code it. I'm just making some space on my table. It's too messy. Yeah. We have given a class with a function, public function, that is same tree, which accepts, which has two tree node, and let's see how tree node is a structure with integer and left and right, along with value left right. That is nice. Along with a function that accepts, if we initiate it like that, that means null pointer is 0 and right pointer is, like, left pointer is null and right is also null. And if we do it in this way, then in that way the value goes to this. Okay, this makes sense. I don't think we are going to initialize anything for this one, but these three things are pretty useful. I'm doing LeetCode after a very long time, especially for trees, just exploring. Maybe I have done it previously, this particular problem statement, but exploring in terms of what I used to know previously and what I have forgot now. Okay, let's see. Uh, firstly, what we need to do is we need to check whether whether the current values are equal or not. Okay, so what we'll do is, we'll, instead of doing this, we'll have a boolean and we'll check whether the condition right now, because our initial condition was whether our q is equals to p, or like I can do, just to make it look more structure, p is equals to q. That is nice. And what we, and of course that we need to get the not const, it's C++. So uh, I'll do the same thing for the left and right, but I want to do it recursively. So how will I do it? I'll do it for like that. For left, what I'll do is I'll just call is same tree. Okay, for P, and here I can see that it has a left pointer associated with it, so I can easily call this pointer in C++ like this, maybe, or maybe I'm wrong. Yeah, I think this is how you can do it. And then Q will take the lift, like we'll call Q with the lift as well. So it looks like here we checked P and Q are equal, then we want to make a recursive call to check the left values for P and Q both. So I'm passing the root as P, left of the P, and then the root for Q as Q's left. That is nice, and then it will land here and check this condition. Absolutely right. Okay, now we need to do the same thing for right, is same tree. Okay, P right and then Q right. That is nice. Again, I would say. So we have conditions checked. whether p is double equals to q, and we have got it for the left and right as well. If all of them are true, if all the conditions satisfies, then in that regard, condition and, because these are booleans, left and right. Okay, and we'll I don't think I need to even open. Yeah, return true, else return false. Yeah, this looks like a complete uh, code, I would say, for the same tree function, but I think something is missing. Let's try to have a dry run on this. If we call it for the given example in the screen, I'll just, yeah, 1, 2, and 3. It will go for 1 and then pass in the left 2 and 2. Makes sense. And then pass right 3 and 3. Then it will go 2, 2 for the left recursion. Then on left, it will check the left and the right, which is null pointer. But that null pointer's left is nothing, right? Because if it does a left on a null pointer, it doesn't mean anything. So it will go in an infinite, I would say, sort of way, and which is not fine. So what we can do here is we can have a base condition. Yeah, if p is equals to null, or not this, q is equals to null, in that regard, just return uh, if p is double equals to q. If that is the case, I would say, then yeah, if p is double equals to q, yeah, we can do that, I think. And why do we need to do that? Yeah, because if any one of it is null, then in that regard, another one has to be null as well. Okay, this is what my function should look like. Let's try to run it and see. And yeah, here is the run button, and let's see if it works. If it does work, then it's fine. And it says no, it is not going to work. Oh, okay. 1, 2, 3, 1, 2, 3, false, expected true. I think I made some mistake and I want to figure out what I am passing in. I'm trying to understand what happened over here. How it should be. And I'm sorry, not a bitwise operation for the booleans. Okay, again it failed. For the first test case, it says p is equals to null or q equals to null. Return if that is true, condition is same tree, p is left, q is left. Okay, and then it's same tree, p is right, q is right, and then in that case, return. Okay. Oh, okay. I think uh, we did a very classical mistake over here. We considered the nodes as the values itself, but it is not the case, because here we need to compare one with one, not the node with the node, root node with the root node. We need to compare the structure, but not the way we are doing over here. What we need to do is, yeah, I remember these were the days when I used to do, when I was learning trees, and I used to make these sort of mistakes. I think it's a whole circle now. I'm again back to this, but yeah, that's nice. I think I was able to mm, bypass that. Let's try to submit it and see if it works. If it does, then it is nice. If it doesn't, then it seems like it worked with 100%. Like my code beats 100%. I don't trust that, but that's nice. So this was it from my side for this video. Let me know if you have any further questions that you want me to solve, or else I'll experiment with whatever I'm doing, and and you know that how consistent I am with this particular channel, which I'll try to be more consistent. But yeah, thank you. Bye bye. Take care.